So today we're going to be looking at how do we find the nth term of an arithmetic sequence. So how do we actually find future terms? Now, at this point, you're probably thinking, oh, well, you can just generate them. But that works for small numbers. It doesn't work for some larger numbers. Imagine I wanted to work out T80, the 80th term in the sequence, right? Well, I'd have to work out T1, then I'd have to work out T2, T3, T4, dot, 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 dot. It's going to take me forever. There's got to be a better way, especially when all we're doing is repeatedly adding the same number, this d, this constant d. And in this case, our d is plus 3, as I'm sure most of you have realized. And our starting term, t1, is just 5. So t1 equals 5, d equals 3. Now we have a rule. Now it's different to a recursive rule. It's actually what we call the nth number. So it's our Tn formula. Basically, rather than telling us the next term in the sequence like a recursive relation, a general rule allows us, or the general formula, allows us to predict much into the future. We can predict any term of the sequence using this. And the rule is this: T1 plus n minus 1 in brackets d. That's the rule. That's the whole rule. On top of that, it's in fact a rule that is on your formula sheet. So it is not one that you have to memorize, but it's also not a particularly complicated rule. So what do we have? We have 4 things here. Tn is the nth term. T1 is then the first term. N is the term number. So it's basically the number, which number of the sequence is it? And D is the common difference. So that is all of the information we need to know to use the formula. And in the end, the formula is going to keep Tn and n like our explanatory variable and our response variable. So they're not going to actually be substituted in until we actually want to do something with it. So for this one up here, let's use the general rule. So we know T1 equals 5 and we know D equals 3. So we would get Tn is equal to 5 plus n minus 1 times 3. Alrighty, so we've just substituted in T1 and we've substituted in D. Alrighty, so let's go through now and simplify this because we've got those annoying brackets on the right. So let's get rid of those brackets. So if you remember from expanding brackets, we're going to go 3 times n, negative 1 times 3. So 3 times n is 3n, negative 1 times 3 is negative 3. And then we can collect like terms. We've got 5 and we've got negative 3, so that can simplify to 2 plus 3n. And this is our general rule. We can now go one step further and actually use it. So what I said before, I wanted to find the 80th term of the sequence. So in order to find the 80th term, well, I need to set n is equal to 80. So there's an n on the left, T80, is equal to 2 plus 3 times 80. Right? I'm just substituting in the n. And so now I just need to work it out. So 3 times 80 is 240, plus 2 is 242. And so the 80th term of the sequence is 242. So this is the general rule. This is how it works. I'm going to go through one more example, and then we're going to move on. So let's have a look at the sequence 18, 14, 10. Dot, dot, dot. Alrighty, so T1 is equal to 18, and D is equal to negative 4. So using the general rule, oh, and we want to generate, say, T20. Slightly too much for us to bother doing every single term, so may as well use the rule. So T1 plus n minus 1 D. There's our rule, and we're substituting in t1 equals 18, d equals -4. So Tn is equal to 18 plus n minus 1 times -4. Now we're going to expand out those brackets, and this time something different is going to happen. When we expand out the brackets this time, we're going to get -4 times n, which is -4n, and -4 times -1, which is actually +4. And so we get Tn is equal to 22 minus 4n. And that's our general rule. And since we want to find out the 20th term, we're going to substitute n equals 20. T20 equals 22 minus 4 times 20. 4 times 20 is 80 plus 22 is 102. Oh, wrong way around. 4 times 20 is indeed 80, but we're subtracting. So it's going to be -58. Alrighty, so there's a little bit of practice of using the nth term sequence. Alrighty, I'll see you in the next one. Goodbye.